So, question number 4. We're going to be looking at the reaction between iodine gas and chlorine gas to make iodine monochloride, which it looks really cool. You guys should look it up on Wikipedia. It's like this cool like red-brown gas, and when it solidifies, it becomes like these black-red crystals. It's really, really cool looking. I would definitely recommend looking it up. All right, so we have this reaction. We're going to find our delta G naught for this reaction. So we're given a couple pieces of information. We have our delta H naught is equal to negative 274 kilojoules per mole. Keep that unit in mind. We'll be coming back to that. Our delta S naught is positive 97.5 joules per Kelvin times mole. Again, keep your units in mind. Then our temperature that we're working at is 25 degrees Celsius, so normal room temperature. If we go down to our lovely delta G naught equation, we see that we have our delta H naught minus our temperature times our standard entropy, right? But all of our units are kind of gummed up here, so we're going to have to convert a couple things. So let's get working on that. So starting off, I'm going to put everything in joules, in Kelvin, and in moles. So that way it's sort of all the same as my delta S. We could do it for any of these, but we just want to kind of to keep it everything looking nice and maybe make it for our delta S. So we're going to say is equal. I'm going to use red for our delta H. This is going to be negative. Remember, always keep your signs around. 274,000 joules per mole. Okay, excellent. Now we're going to use our temperature in green. We're going to say minus our temperature, which 25. How do we convert between Celsius and Kelvin? It'll be, we're going to add 273.15. So that'll give us 298.15 Kelvin. And we're going to multiply that, my entropy, mark color. We're going to multiply that by 97.5 joules per Kelvin times mole. All right, so now let's go through and let's see if we can cancel anything out, because that's always nice. It always feels like we're cheating. I see that we can cancel our Kelvin here and our Kelvin here, and now we are left in joules over mole for our delta H value, and we're left with joules over mole for our delta S value, which means that we can subtract these two things now, which is really nice, because then we can actually work with this. All right, so if we get that, that will come out to be, I'm going to use green again for delta G. That's going to come out to be 303,000 joules per mole, or, say equivalently, 303, oh sorry, negative, there we go, kilojoules per mole. Remember, always watch your signs. All right, so we have a negative delta G, which means this will be a spontaneous reaction, which is nice because we can look on Wikipedia and see that this reaction actually does work, and we can see the gas that it makes. So our number matches what our result should be. I think we're done. All right, guys, have fun with this one.